Hey folks, Jonathan here. I want to give everybody a little update on the engine, both engines, and another engine. But anyway, few issues with this one. I was having some mag issues, so I actually wired up a Model T Ford buzz coil and using the same points and timing for this. Really what I was having was starting issues with that. When the impulse coupler would kick, it would fire, but of course when the impulse coupler worked on the first rotation, it automatically popped out and didn't work on the second rotation. So when it came around, it wasn't turning fast enough for it to fire the second time. So what I've got is it's sort of a weak mag, but what we've decided to do is we're going to run a set of points. I'm going to run a little generator on this. And the reason I'm going to do that is because this bike may end up having some lights on it and stuff before it's over with. But I'll still be running, I won't be running the mag, I'll still be running the same plug wire. It'll still have a chain drive going to the magneto. The points will be there, but you'll have to see what I'm going to do to understand it. But I promise it'll be nice. You'll really like it, and it's still going to look period correct when I'm done. But another issue, which is a little more major issue. You know, tuning on this, trying to get it running like I want it, I was having some issues. Excuse me. And if everybody remembers right, or the people that have watched the video, you know, I was going back and forth about the timing, or not necessarily the timing, but the cam and the lift on this thing. And when I originally designed this in my head, you know, I was wanting 220 thousandths lift, 230. You know, that was, and I believe I even said it in the video that, you know, that's what I was shooting for. And I went as high as I could possibly go because the cams was only 108 thousandths lift, and so I went as high as I could go and still keep my push rod straight, or as straight as I could get them, you know, where they was not cocked in real far. And then of course I moved our fulcrum point from here out and made this end longer, and to give us more lift. Well, what we ended up with was 165 thousandths lift, and 165 thousandths lift is not enough lift for the RPMs that I want. You know, it runs good at idle, it revs quick, and it runs good, you know, when you give it a little bit of gas. But if you open it up wide open, you know, it should be revving. I mean, revving good. Instead, it's coming up and it's popping through the exhaust and the carburetor. And not real bad pops, but, you know, it's popping some. And I've got some video of it running. I'll go ahead and I'll show you that now. Okay, hopefully you'll see what I was talking about the popping. You know, it idles good, revs good, but, and I know that's the issue, I have no doubt. You know, I can set the valve lash at, let's just say I set it at 10 thousandths, and it runs, you know, this good, and then I reset it at, you know, 1 thousandths, 2 thousandths, really close, and it runs so much better. And what it is, it's actually, when I tighten the valve lash up, it's increasing the lift on it. And it's not going to take much, because, you know, if you're changing 10 thousandths and it's, you know, adding as good as it did, it's not going to take a whole lot. But I'm going to hold off before I do anything, because I don't want, I can cut these, I can put a slice in them, shorten them up, bring them in, but that's going to angle my push rods, and, you know, it's really not what I want. So I've got another plan or another idea, and I'll show you on our other engine we're working on, because I'm going to do it to it first, and if it works out, then we'll jump on this one. Of course, I had to pick a time when my light was out here behind me. Maybe it'll come on while I'm videotaping, but let me get around here where you can see good. Okay, I've just got this stuck down in there. I was just playing, getting some ideas on size. You see I've got my plate done. Have not drilled it and bolted it in or anything yet. Got my gear just slid down on. I've got to make a bushing that goes behind it that actually is bigger, so it holds the bearing race, or goes up against the bearing race, and you know, holds everything together right, and that'll set the gear out just a little bit. Anyway, so this is going to mount over on this side, you know, not all the way over like the other ones were, but somewhere around in here. And you know, it's going to operate our lifter coming through here. And you know, the same issue. I've got a 108. The old engine had 155. I'd love to go with 175, 180. And I probably need to go at least that, maybe more, because the difference on this is the Kincaid engine that this cylinder came off of probably ran a max of 1,000 to 1,200 RPMs, and we're wanting to get 3,000 RPMs. So, you know, that's automatically, you know, an engine's a pump, so it's all about airflow. And if you don't have enough lift, you don't have enough airflow. So we will probably end up going higher with it. But here's my plan. I'm going to use this other gear that the lobe's bad on instead of using this one. Okay, Honda made a 125 motorcycle. Now I don't know if they exported them to United States or not, but they made a motorcycle that had a single cam in the center. This is pretty recent. This is not no real old bike. It had a single cam in the center, and you can imagine it, you know, if we had two lifters, just sort of like what we've done on our last engine, but we had a pivot here on each side and a rocker assembly, or you can call it a lifter guide, whatever you want to call it. But anyway, come off of the cam over to your pivot and up, and you know, sort of, I guess it would be angled down, but I mean, they had it kind of a weird angle. But anyway, what was happening was they was using a single cam to operate two valves. And it's pretty easy to do. You know, this one's closing when the lobe gets here, and then as it turns a little bit, it starts opening the other one. So I mean, it wouldn't be a problem to build that. It wouldn't be a problem to you know, to make that work. You know, I'm not planning on doing that on this, but I'll get to my point here. The point is when they built this particular design, they used a plastic cam lobe, and I think just the thought of a plastic cam lobe would be enough to prove to me that it wouldn't be a good idea. But they went on and produced it and put it out, and of course it had problems. So there's a company in China, or could be multiple companies, but they started making the gear sets with the cam lobe. And the gears may be plastic too. I know the lobe is, but the gears may be plastic. But they started making these gear sets and selling them, and as an update for them motorcycles, and building them really cheap. You know, we're talking about shipping and everything to the United States. I can get this gear, the cam lobe, and a center shaft that went through the gear for $17. That's shipping and all. So they've really mass produced them, you know, CNC machines, and I'm sure they just popped them out as quick as they could. But I just stepped on my pen. Anyway, we're not going to be able to use the gear because the gear is a 2.95 diameter, so it's almost 3 inches, just under 3 inches, 5/1000 under. So it's too big to fit in where we need it. It's probably too big to go in there, I'm sure, because the other gear is going to be bigger too. And I think it's like a 44 and a 22 tooth. But it's not a straight cut tooth either. It's a beveled gear. So it would be really nice to be able to run it, but we'll have to do that later, maybe do some redesigning on the crankcase to run something like that. But my point is, the lobe is separate from the gear. The lobe actually slides through in a bigger hole, and there's one pin that sticks off the lobe that goes through a hole, a single hole that's a little farther out on the gear, that keeps the lobe from spinning. And on the back side of the lobe is a snap ring. So the lobe you can take off and put in your hand, you know, be completely separate from the gear. Well, that lobe has got some pretty good lift on it, and I'm guessing, I'm hoping, you know, over 200, probably 220, something like that. And we'll see for sure when it gets here. But I ordered one, and what I want to do is machine. I'm going to take this other gear that the gear is still good on, you know, because this one's been brazed on. What we're going to do is we're going to machine it out, and we're going to put that lobe on one of these gears, and that way we can, you know, get the lift that we need. And if it works out like I'm hoping with the lift and everything, and we are going to probably take and do both the cams in the other engine to go ahead and get the lift up on them. And I'm sure it'll probably have a little better duration. You know, we're talking about a cam that was designed, you know, 100 years after this cam. so, you know, or close to 100 years. So should be a better design. So that's sort of what we're waiting on this and the other engine. Working on getting parts together for the other engine. Of course, you've seen the transmission. I'm working on the hubs and the what I'm going to use for rims and everything, because you really need some parts before you can start just jumping in and building a frame, and you know, the forks and stuff. We need to have a width and know what we're going to do beforehand. And I'm, you know, up in the air between whether I use a set of hubs that I've located or if I build a set of hubs. And I may build them. And I actually started working on something. I'll show you. I started cutting this piece of steel here. I started with my old saw, and my blade is just so far gone. That blade has been on that saw for 2 years, and I've cut everything you can think with it, and it's had it. It just went so far and wouldn't go no farther. So somebody had gave me this old bandsaw, actually a good friend of mine, and he was moving, and so it had a couple little issues, and I straightened them out, and I got it in here and got it hooked up, and the blade had a little kink spot in it. It was kind of worrying me, but I said, well, I'll try it. So I threw it in there, and I think the blade cut about the same depth as what the other blade cut on the other side, and then broke. So I went ahead and ordered a blade for this, a bunch of blades for the other one, and I ordered me some new inserts for my tooling. I've never had new inserts on any of my tooling for my lathe, and I'll show you something on it in just a second. But anyway, what I was doing was cutting this off. We're going to set it up. If I go ahead and do it, I'm going to set this up in the dividing head. We're going to drill the holes for the spokes. What we'll do is drill each side, and then after that we'll machine the center out where we want it. We really need to have something to hold on when we drill them 18 holes on each side, and because it's going to be a 36 spoke rim. So anyway, you can buy basically the hub that I'm building. You can buy it as a reproduction for like an Excelsior motorcycle, nickel plated, really pretty hubs with the axle and the nuts, you know, no rim, no spokes. They want $429 for it, and I can buy the plating kit for nickel and build the hub, you know, way cheaper than that. So even buying bearings and stuff. So anyway, I'll show you something on my lathe here. Okay, I just want to show you this one example here. This is the kind of holders I like to use, which is just regular, you know, they're actually 3/4 holders, and they hold a carbide insert. And it's kind of crazy, but all the years that I've been doing machining, playing, you know, not professionally in any way, but just all the playing I've done here, I've never bought new inserts. And I actually had to go in and I took the numbers off of these holders, and searched and found there it is. I searched and found what insert fit in it, because I'd never bought inserts before. But as you can see, I've ground into the insert and ground into the tool, and you know, just to clearance to be able to keep using it and using it and using it over the years. So I finally ordered me some new inserts, and I don't know what's going to be like cutting with a new one, because like I said, I've never done it. And I've went through some grinding wheels on my grinder, sharpening these things, because that, of course, that carbide's bad on them. Everyone should know, or does know. And but anyway, so I'll have some new inserts. I actually ordered inserts for 3 different holders. I've got 3 different styles, so that'll be really nice. And I'll let you know how they work out new in comparison to all the ones I've sharpened over the years. Okay. Here we've got, it says JLO, but it's actually ILO is the company that built this engine. This was built in Germany. I'd shown this before, probably 1.5 years, 2 years ago. I'd done a video on oddball engines, and of course this is kind of an oddball engine. This is a 198 cc, and I don't know that I knew what it was before, but it's 198 cc. They call this a 200. Water cooled, 2-cycle, and this was actually from 1928 or 29 up to about 1932. They made a cycle car in Germany. When I say cycle car, it was a sort of a truck. It had 2 wheels in the front, 1 single wheel in the back, and they said top speed I think was like 17 mile an hour, but they actually hauled cargo and stuff, and in them. But this was the first design that came out was called a Tempo T1, and they had some issues with it and stuff, and then they went to a T2 which had a 400cc engine, and they made a few designs, and they went back to a Tempo T6 that had the same engine, but they made more of the T6s than anything, and that's still only about 3,000 of them made. So there's one Tempo T6 here in the United States, and they're claiming it to be the only one here in the United States. And believe it or not, they're wanting $80,000 for it. And now it's complete. Don't get me wrong, it's not a motor. I mean, it's a whole bike. This engine here is missing some parts. It's missing the flywheel inside, and a few other pieces and parts here and there. And of course, as you can see, no carburetor or anything like that. My plans for this was to get it running and do some fabricating and modifying to change it around. And with it being so rare, I was worried that I was messing up something that somebody may be able to use. So I went on some German websites, or actually a German Tempo website that for collectors, and I put some information on it, hoping I can get this in the hands of somebody that can actually use it. And but anyway, if we don't end up, I'm probably going to do some machining. As you can see, that's how I got it. Crankshaft's there, no flywheel, no nut, and it's got the magneto, but it don't have the flywheel. And there's no drive. There would have been a piece in here that went in that drove the points as a just to open a lobe of some sort. But I can fabricate and make some stuff to make this engine run. It does have good compression and all, and it actually has a compression release on the end of it, and it runs the old 1/2-inch pipe threaded spark plug, I believe. That might be an 18 millimeter. Let's see, it's loose. Yeah, I think this is the old 18. Oh, let's look, it's going to surprise me. It might be a 14. No, 18. Okay, yeah, the old 18 millimeter. You can see there's a lot of oil and stuff in it, which is a good thing. And this is thermosiphon cooling. This is the only water pipe on it. This is carburetor. Exhaust is at the bottom. And the thermosiphon works off the basis of heat rises. And it works. People can tell you what they want, but and it may not work as efficient as good as a pressurized system, but with a water pump. But basically the theory is heat rises, and if you've got enough water, let's say if you had a 5-gallon bucket above it, or tank with a hose running to it, and you just filled it up with water and had water in this cylinder, as the heat, the water heated the cylinder, or the cylinder heated the water, it would actually come up through and rise, and cooler water would be going into here. So it would never get hotter than your coolest part of water. So if the top surface temperature of your water was at 212 degrees, down low, it's going to be cooler, and it's going to be drawing that cooler water. It's not going to draw that 212 degree water off the top, and then the heat, of course, will basically exchange out the top, and because it's a non-pressurized system, you'll lose heat out the top, and water will be cooled off and just keep basically thermosiphoning or circulating on its own. And that's how the cooling system worked, and that's how a lot of old cars and old tractors work. And there's nothing really wrong with that system. But anyway, if anybody knows anything about someone that has one of these, from what I can understand, the serial number is 1617. There's a 150 in front of it, but I think that's the series of engine, and then a 1617. And so that's about midway through production. And but very rare here in the United States. I think it's pretty rare in Germany too, but I'd love to get this into the hands of somebody that could use it. And I'm not wanting some stupid amount for the motor. Like I think that the Tempo that's here, they're wanting $80,000 for. I think that's just pretty much a joke. But yeah, I prefer to get it in somebody's hands that could use it. If not, we'll end up doing something with this. You know, I can't run this cylinder as an upright cylinder, even if I move my water neck, because there's an area in the top of this head that would be trapped. You'd end up with an air bubble in this head, and it wouldn't cool right, you know, thermocycling. So it needs to be laying down to run right. So, you know, I could use one of my blocks and build this into a sideways engine, I guess, but, you know, still two-stroke. I'm not much into two-strokes. Most of you, or some of you may have figured that out by the engines I build. Two-strokes, to me, are easy, simple. I just don't like them. I don't like, I never have liked them. And, you know, if you read a lot of books from the early 1900s and 1800s, they had a lot of trouble with two cycles, getting them to be consistent. Not necessarily that they wasn't good and, you know, dependable. It's just they wasn't consistent. They wasn't consistent on fuel. They wasn't consistent on power. They wasn't consistent on running. And so that's why there was so many four-strokes still being built, even though two-strokes were simpler to build, easier to build, cheaper to build. You know, when you're completely doing away with the valve system, and you know, it's not too hard to build a two-cycle engine, and they just they're just not, they don't last as long, and it's just, you know, there's just a lot of little things about them that I just don't really care for, and that's why I don't build them. I wouldn't mind, you know, something later model motorcycle or something or running them, but I just don't prefer to build them for myself, and the sound of them just not, it's not the same to me. And like I said, to me, a two-cycle's just a way simpler engine to build, and you know, no, it's not much for the timing issues on them, but or cam lift or anything like that. So anyway, I appreciate everybody watching, and I'll keep y'all updated on everything that, you know, I'm working on here. I'm wide open on the rollback and doing body work now, so the weather has finally changed, and we're finally getting some cool weather now, and I hope everything, you know, is going all right for everybody down in Texas. I know it's rough down there, and I just wish I was closer, because I've got boats, and, you know, if I was closer, I'd sure be out there, and I don't know that I wouldn't just get in the way, but yeah, but anyway, I hope everything's, you know, everybody's all right. But all right, appreciate it. Until next time, bye.